Hey guys, GreatGamer34 here. So today we're going to be addressing our flags and setting up our flags to do things. So I want to show you what is planned over here, or is planned for that one, which I've done on this one. So what we're going to do is we have our line here that's the output of our ALU. And what we're going to do is, it's kind of hard to see, but we take that output and put it to redstone repeaters, and then OR it all together on this line here, and then save it into a register. And then that register gets outputted over there. And then we have this carryout, which gets boosted because the carryout gets a very weak signal under certain conditions. And then it gets into a register, and then the carryout goes into this register over here. It comes over here. This we'll be worried about later. This here is a decoder. So it's basically when a certain inputs are on, it decodes to this torch, and then over here is a decoder that decodes to these torches, and then this is an XOR that says if these are off, then everything comes off, and then it allows you to branch, or it doesn't allow you to branch. So this is what's going to check for our flags. If true, it checks if our condition meets the flags that are true, and if they are, then it sends a signal to the PC. And so that's what we're going to be working on today. Okay, so here we are on the CPU, and as you can see in chat here, I selected it and I saved it as tutorial CPU 4, so I haven't edited anything on it yet. And so we're going to start with these blocks that are here, and we're going to basically add repeaters like this, and then we also want to come up and over like that. Whoops, I want it like this. And then we're going to go like that. I'm going to highlight the redstone, and we're going to stack 7 times, like that. Oh, actually we're going to undo that, and we're going to stack it like this. Bad. There we go. Nice. Okay. Then from here, we're going to go like that. We're going to use the color of our busing, and it's going to go in like that. Oh, and this ALU is made by Koyarno, if you guys haven't noticed. Okay, so this is going to be our flag that says when all the bits are off, this is off, but if any of the bits are on, this is on. And so what that ends up doing for us is telling us if when we subtract, if there's nothing on the output, that means the inputs are equal, because that means the output was 0. So if the output is 0, we're just checking for if the output's 0. This is called the if 0 flag. And so we're saying if the output is 0 when we do a subtraction, then we know the inputs are equal. If the output isn't 0, then one has to be greater than the other, and then depending on if the carryout is positive or negative, we know if it's A or B. So that's what we're going to do next. Now we're going to come in here, go like this, and so we need to split this off. We're going to, we want our busing here to come over like this. So we want this to be the right for the second one of these. Okay, chat's going crazy. Okay, the reason this comes up and over is because we're going to have to pass this through it, like that. I guess that's a little dramatic. I guess we don't need to go up like that. Okay. And so we need this. And then a line like that. Okay, and then if we have this guy come in that. And then this is going to be the output of the register. Okay. This here is the carry out, which needs to go be saved into a register. So what I'm going to do is I'm going to go like this here. Oh, not with that. I want a repeater. We want another repeater. And then these two are going to be hooked up. Actually, no, scratch that. We're going to, yeah. I don't want this to be that high. Let me see how I do it on the other. Okay, so what we're going to do is we're going to break that like that. This is not going to go like that. This is not going to be like that. This is going to come over. Like this. Okay, good. This is going to get locked like this. This is going to get locked here like this. This one is going to come up and over. This is going to come like this. Okay, and then over here, so we want to come like this. And then the moment it gets past this torch tower, we drop down one. And that should come and match right over. Nice. And then we want the second one to match that. And then just gotta drop down right there. Perfect. We want our second one to match it right here. So we can get rid of that. Alright, so this one comes over and that one comes over and they line up nicely. And then we're just going to come up like this. And unfortunately, oh actually no, we can do it. Yes. We could do this, just like that. Good. I can lower this one here, just the same. Just like this. So I'm trying to keep the max height all at one level here. Okay. And then last thing, I'll get rid of that. Last thing we want is, or the next thing I guess, whoops. Bring this up and over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm not sure how far I want to bring this. Oh, and the other thing we have to do is go like this. So let me reference what I want to do for that. Alright guys, so Bandicam messed up again when I'm recording. So here I am doing this again. So I left off here. We built this. So anyway, what's going to happen is out of the carryout flag, comes into here, comes down and over, and it also comes up over exactly over this line. Up and over, and they're evenly spaced every other one, so it's pretty easy. Then the right for this comes over here, but we're not worrying about hooking that up this episode. The output for this comes over here. We don't really care where it actually is, it's just over here somewhere. These half slabs are because of the torches underneath. Okay, so the output of here, we had to put a block here to extend this to make this reach 15 signal strength, and it reaches into here. Okay, Cool. So what we did, and I'm not rebuilding this, so what we did is we brought the repeaters down like this, and we built diagonally down like this. We built 1, 2, 3, 4, 5 diagonally like this, and then up here we did 1, 2, 3 diagonally like that. Then what we did is we had to test for our flags. So we had to encode our flags here. So what we did to do that, so we came down here, we put our CPU in subtraction mode like this, and now it's doing A minus B, and we want both our inputs to be set to 0. So it's doing A minus B, 0 minus 0, which is equal to 0. So this should be our equal to flag. So right now, this top one we want to be our equal to flag, so because this is our output when they're equal. So we put a torch and a repeater like this. We link them up and put a torch. Don't worry about the rest of the stuff, I'll explain it. So just worry about building this decoder. So we place a torch like that. Now we want to do A is greater than B. So that's the greater than statement. So we're going to flip some switches on over there. And then we're going to update our flag here. That really only needs to be a button, not a lever. But now you'll see both are on. So this one over here, there's a torch there. Then what we did is we came over one, placed a torch, ORed them together, and this is our greater than flag. So this one is our branch of equal to. That's our greater than. And then our less than flag, we kept this over, we dropped down one, placed a torch on it like that. Over here we have our repeater. They OR together, and this is our branch of less than. Okay, so we have a branch of less than, and to prove that, we will make A less than B. That's what that means. So like this, and then we'll update our register. And then now you'll see this one is true. Okay, so this one is true. Now what are we going to do to check for these? Alright, so what we're going to do is we're going to place a block like this here, and then next to it like this, and we're going to build these XOR gates. So the XOR gate gets powered here, this gets ORed there, and then comes into here. So this is subtracting full signal strength from this one. Anyway, so we do that, and then we build the same structure on this side. And then we take the outputs and then OR them together like this. It doesn't really matter how you OR your outputs together, as long as you just OR them together. Now what we got to do is we got to build a decoder onto this. So the way to do that is you come over here, and then you place a block above each part right here. You don't have to do it on this side, like this, but you do it on that side there. And then the way we start this is we're gonna put a repeater, or not a repeater, we're gonna do a torch, repeater, repeater like that, and then here we're gonna do a repeater, torch, repeater, and then we do half slabs up, so our signal can only come up. And so this is a decoder. So this is basically saying 0, 0 for a branch of equal to, which matches our 0, 0 here. This one is saying our 1, 0, which matches our 1, 1 here. And then this one is saying our 1, 0, which is matching our 1, 0 here. So what this is doing is these don't have to line up over here. What this is doing is this is saying, oh, your flag is saying right now it's equal to, or your flag is saying this is less than, or your flag is saying this is greater than. And so this is coming and telling us what it's saying. Over here is what we're searching for. Are we searching for equal to? Are we searching for less than? Are we searching for greater than? So if we enter 0, 0, that means we're searching for equal to. Well, we know equal to is up here, so 0, 0 gets decoded up here. Alright, what if we enter 0, 1, so the number 1, the second one, because we have four flags that we can search for technically, but we're only searching for 3. So 0, 0 is equal to, 0, 1 is going to be greater than, and 1, 0 is going to be less than, and that comes from our instruction set. Then what we do is we place a block like that, and like that, and we power in like this and put a torch here. And then the other thing that you guys are going to have to do is you're going to notice that this decoder's in the way for you have to remove it out. So what I did is I kept above this bit, I kept 1, 2, 3, 4, 5. Yeah, I kept 5 layers above this right here. So that gives us 12 instructions. So it goes up to 12 right here. And that gives us clearance. And then if we need more instructions, we can put them on the back end up and over here. But this gives us some room. And then so I'm going to explain basically how this works. So right now the flags is saying that our input is less than, A is less than B. But let's say, so we say, we run our code, and the way our code works is we have to say, do some stuff, then if A is less than B or something like that, or if A is greater than B, go here and run some code, else just continue running code, right? So that comparison that we do, or that jump that we do, where it jumps to another line, takes 2 steps. First, it's the comparison, which does A minus B, and then saves the flags here. So the compare operation is going to have to know how to write these flags. And then the branch operation reads the flags from here and compares them to what we're searching for. So let's say we have the less than flag, but we're searching for equal to. So we have less than, and 0, 0 is equal to, so we're entering 0, 0. Let's say, is what I'm searching for in the flags? We ask it, oh, magic conch, is it? And the output of this torch says, no, it's not. Okay. Now let's say we were searching for less than. So we put a 1 in here. And then we go, oh, magic conch is what we're searching for in the register. And it goes, yes, yes it is. So all this does is, this is going to come from our branch instruction that says, when our branch is happening, here, allow the output of this to work. Else when the branch isn't happening, we don't care about the result. So this way we can only get something going to our program counter, because this is the output of this. When this says, okay, go ahead and branch, this goes to the program counter, and whatever values are going towards the program counter, it's going to branch to. So we have to make sure that we're only telling it to branch when we're on a branch instruction. So this way the values that are going to it don't accidentally get branched to, because we're not going to put a mux on there. We want to try to minimize the amount of control logic we have to build. So we have to be smart about how we built this thing. And so this is a nice way here, and compact way to do the flags. And I'm sorry that this happened off camera. Somehow Bandicam messed up and didn't record it. So I'm hoping I'm able to do enough fly-throughs and stuff. It's basically just these XORs stacked offset from each other. So the way the stack works is it's over 1, or over 2, up 2, and then over 2, and then up 2, like that. Over 2, up 2, over 2, up 2. And then you just build the decoder on top of it here. And so the input to this decoder will come from our instruction decoder here. Or not our instruction decoder, sorry, it'll come from our instruction set. So basically the way that'll work is the inputs to that decoder here, the branch of equal, greater than, less than, or underflow. We're not going to have the underflow part, so I guess I can get rid of that. Like that? Okay. And we'll get rid of that. Okay. So that's why the order of those were the way they are. So the decoder is going to get input from the second set of, or from the rightmost bits of the right line. Because if you think about it, during a branch, we're not writing any register, so that part of the instruction set isn't used, and we can use that to then give instructions to say what else, what branch we want. So that's where these bits will come from. And anyways, that's this tutorial. Sorry that it's so long, and sorry that it got deleted. The video coverage that I wanted to show got deleted. Anyway, I'm hoping to try to minimize these errors as it moves on. And I'll give you one last final shot of what it looks like over here. So feel free to pause the video if you need to rebuild any of the stuff here. But you'll get the world download and stuff for the next tutorial. So yeah, sorry about the errors, but at least we'll be all on the same page every time I post a new video.